Imagine a world, not so far from our own, a world that burns with an intensity that defies the cold, dark vacuum of space. This isn't a distant star, or a fiery planet close to the sun. It is a moon orbiting the gas giant Jupiter, a place of constant violent creation. This is Io. It is, without a doubt, the most volcanically active body in our entire solar system. Its surface is a canvas of chaos and color, painted with the raw energy erupting from deep within its core. It's a place where hundreds of volcanoes are active at any given moment, spewing plumes of sulfurous gas hundreds of kilometers into the sky. So, what is the secret behind this relentless fire? How can a small moon, so far from the sun's warmth, be so incredibly hot? The answer lies not within Io itself, but in its relationship with its colossal neighbor Jupiter. For centuries, Io was just a tiny pinprick of light in the night sky. It was discovered by Galileo Galilei in 1610, along with its three large siblings. For over 350 years, it remained little more than a dot, its true nature completely hidden from us. When NASA's Voyager 1 spacecraft flew past Jupiter in March 1979, it sent back the first detailed images of Io. Scientists were stunned. Instead of a cratered moon-like surface, they saw something completely different. It was a bizarre, colorful world with no impact craters at all. To truly understand Io, we must first appreciate its precarious position. It orbits Jupiter, the undisputed king of our solar system. Jupiter is a monster. It is so massive that it could swallow every other planet whole, with room to spare. Io is the innermost of Jupiter's four largest moons, orbiting incredibly close to this giant. It is trapped deep within the planet's powerful magnetic field, a region of intense radiation and cosmic energy. This proximity means Jupiter looms large in Io's sky, appearing more than 20 times wider than our full moon does to us. That all changed on a cold winter's night in January 1610. An Italian astronomer named Galileo Galilei pointed his newly crafted telescope towards Jupiter. He noticed four tiny points of light, like little stars, huddled close to the planet. They were not fixed stars. They were orbiting Jupiter itself. This was a monumental discovery. It provided powerful evidence for the Copernican model of the solar system, which placed the sun, not the Earth, at the center. Galileo named them the Medicean stars after his patrons, but they would later become known as the Galilean moons, Io, Europa, Ganymede, and Callisto. The moment of revelation arrived in March 1979. As the first detailed images of Io were transmitted across hundreds of millions of kilometers of space back to Earth, the scientists at the Jet Propulsion Laboratory were left speechless. They were expecting a world like our moon or Mercury, a grey ancient surface heavily pockmarked with impact craters from billions of years of cosmic bombardment. Instead, their screens filled with an image that looked more like a piece of abstract art. A lack of craters means one thing: the surface is young. If a surface has few or no craters, it must be constantly renewed, with fresh material paving over the old scars. Think of it like a beach at high tide. The waves wash away all the footprints in the sand, leaving a smooth, fresh surface. But they also saw strange, dark depressions scattered across the landscape. These features, which they named paterae, looked suspiciously like volcanic calderas on Earth. The answer to Io's infernal heat lies not in fire, but in gravity. Specifically, it lies in the immense gravitational pull of its parent planet, Jupiter. Io's path around Jupiter is not a perfect circle. It is slightly squashed into an oval shape, known as an ellipse. This seemingly small detail is the key to everything. When Io swings closer to Jupiter, the planet's colossal gravity pulls on it more strongly. This immense force deforms the moon, stretching it out of its spherical shape. This cycle of stretching and relaxing happens over and over again on every single orbit. Io completes one orbit in just 42.5 hours, meaning it is being squeezed and released relentlessly, twice a day, every day, for billions of years. It is very much like taking a metal coat hanger and bending it back and forth rapidly. After just a few bends, you can feel the metal at the bend getting warm. Now, imagine this happening to an entire world. The constant grinding and rubbing of rock deep within Io's interior generates a phenomenal amount of thermal energy. To truly grasp the power of this tidal heating, We really have to appreciate the scale of Jupiter. Its gravity is so dominant that it actually warps the space around it, creating a deep gravitational well. The tidal forces acting on Io are honestly hundreds of times stronger than the forces our moon exerts on Earth's oceans. On Io, the same principle, amplified by Jupiter's mass and Io's proximity, raises tides of solid rock that can bulge up to 100 meters high. Just imagine a tide on Earth that wasn't water, but the solid ground itself, rising and falling by the height of a 30-story building, twice a day. This is the reality on Io. The volcanoes of Io are, in essence, safety valves, releasing the immense pressure that builds up from this continuous gravitational punishment. Scientists estimate that the tidal heating on Io produces about 100 million megawatts of power. To put that into perspective, that's thousands of times more heat than what is generated inside the Earth by radioactive decay. This energy has to go somewhere, and on Io, it erupts onto the surface in the form of spectacular volcanic plumes and vast flowing rivers of incandescent lava. One might ask a simple question: why hasn't Io's orbit become a perfect circle by now? Over billions of years, tidal forces should naturally push an orbiting body into the path of least resistance, a circular orbit where the gravitational pull is constant. If Io's orbit was circular, the tidal flexing would stop. The answer lies not just with Jupiter, but with Io's neighbors. There's a cosmic conspiracy afoot, orchestrated by the other Galilean moons. Io is part of a beautifully synchronized system with two of its fellow moons, Europa and Ganymede. This celestial clockwork is known as an orbital resonance. For every one orbit that the giant moon Ganymede completes, the icy moon Europa completes exactly 2. And for every 2 orbits of Europa, Io completes exactly 4. Think of it like pushing a child on a swing. If you time your pushes perfectly with the swing's natural motion, you can send the child higher and higher with very little effort. Europa and Ganymede are constantly giving Io a perfectly timed gravitational push, maintaining the slight oval shape of Io's orbit, and in doing so, condemns it to a fate of perpetual volcanic turmoil. When we combine the immense gravity of Jupiter with the resonant kicks from Europa and Ganymede, we get a complete picture of Io's power source. It's essentially a planetary-scale electrical generator, but one that produces heat instead of electricity. This internal power plant dictates the entire geology of the moon. Underneath this crust lies the vast ocean of magma, kept molten by the tidal heat. The entire moon functions like a pressure cooker that is constantly letting off steam. Io's volcanoes resurface the entire moon with a fresh layer of lava and sulfur compounds at a rate of about 1 centimeter per year. While that might not sound like much, over geological timescales, it is incredibly fast. It means that the entire surface of Io is only about 1 million years old, making it the youngest surface in the solar system. Any impact craters that form are buried almost instantly. This is why Voyager 1 saw a world without craters. When we think of volcanoes, we naturally picture the ones here on Earth. We imagine a classic cone-shaped mountain like Mount Fuji or Mount St. Helens. Unlike Earth's majestic cone-shaped stratovolcanoes, many of Io's volcanoes are vast, flat-floored depressions called Planetary. These are not so much mountains that erupt, but holes in the ground that leak. On Io, volcanoes are not the exception. They are the rule. There are over 400 active volcanic centers scattered across its surface, making it a celestial minefield of eruptions. Earth's volcanoes are mostly found at the boundaries of its tectonic plates, where plates are either pulling apart or crashing together. On Io, there is no evidence of Earth-style plate tectonics. Instead, the entire moon is squeezed and flexed by Jupiter's gravity. This tidal heating creates a global ocean of magma just beneath a thin, brittle crust. The volcanoes are simply weak spots in this crust, places where the immense pressure from below can violently burst through, releasing the moon's pent-up internal heat. The material that erupts from Io's volcanoes is also far more extreme than what we typically see on Earth. Some of the hotspots measured on Io's surface have temperatures exceeding 1,650 degrees Celsius. This suggests that the lava is what we call ultramafic, a type of lava rich in magnesium that was common on the very young Earth but has not erupted on our planet for billions of years. These incredibly hot lavas are also much less viscous, meaning they flow more like water than like the thick syrupy lava flows we are used to. Some individual lava flows on Io are over 500 kilometers long, far larger than any active flow on Earth. One of the most prominent features, Loki Patera, is a massive lava lake over 200 kilometers in diameter. The moon's volcanoes also produce gigantic plumes of gas, primarily sulfur and sulfur dioxide. The most powerful eruptions can create umbrella-shaped fountains of gas and dust that reach heights of over 500 kilometers. This ejected material then freezes in the cold of space and falls back down, blanketing the surface in colorful layers of sulfur snow. One of the most puzzling features on Io is its mountains. Given the constant volcanic resurfacing, you might not expect to find any mountains at all. Yet Io is home to over 100 mountains, some of which are truly colossal. Busol Montes, the tallest, rises about 18 kilometers above the surrounding plains. That is more than twice the height of Mount Everest, measured from its base. These are not, however, volcanic mountains in the way we think of them on Earth. In fact, most of Io's mountains show no signs of being volcanoes themselves. The answer, scientists believe, lies in the immense pressures within Io's crust. The constant deposition of new lava and sulfur from the volcanoes adds tremendous weight to the surface. This weight presses down on the crust, creating immense compressive stress. Eventually, the stress becomes too great for the rock to bear, and the crust fractures and buckles upwards along massive fault lines. Io's mountains are not built from the top down by eruptions, but pushed up from the bottom up by immense tectonic forces. They are rugged, angular, and often surrounded by steep cliffs or scarps. They appear as if giant blocks of the moon's foundation have been violently shoved into the sky. When we add all these observations together, we see that Io is a world defined by a symphony of extremes. The temperature difference between a dark, shadowed plain and an active lava flow is one of the most dramatic in the solar system, spanning from a frigid -143 degrees Celsius to a blistering 1,650 degrees Celsius. This is a world of fire and ice existing in close proximity, a place where sulfur dioxide can erupt as a hot gas, freeze into snow in space, and fall back onto a surface right next to a river of molten rock. The scale of its features is also extreme. Lava flows hundreds of kilometers long, dwarf anything seen on Earth in recent history. The entire surface is recycled on a geological timescale that is blindingly fast, burying all evidence of its past in just a few million years. On Io, geological time is compressed. Comparing Io to Earth helps us appreciate just how special our own planet is, but it also highlights how diverse planetary processes can be. Io is not just different from Earth. It is a spectacular lesson in just how wild and varied the cosmos can be. We often talk about the Goldilocks zone in our search for life. This usually refers to the habitable zone around a star, the orbital path where a planet is not too hot and not too cold for liquid water to exist on its surface. But Io forces us to ask a different, more challenging question. What if the key to life isn't just about the warmth from a star? The heat is not evenly distributed. It's concentrated in specific volcanic regions, creating an environment of incredible thermal gradients. Could it be that somewhere between the blistering heat of a lava channel and the frigid cold of the sulfur plains, there exists a narrow zone where conditions are just right? On Earth, we have discovered ecosystems deep beneath the ocean, clustered around hydrothermal vents. These communities thrive in total darkness, drawing their energy not from the sun, but from the chemical reactions fueled by heat from the Earth's interior. Could Io, with its immense internal heat engine, provide the right chemical ingredients and a stable energy source for similar chemosynthetic life forms to arise? The raw materials, like sulfur compounds, are certainly abundant. The question then becomes one of stability. For life to begin, you need a few key ingredients. Scientists often refer to the recipe as liquid water, the essential chemical elements, and an energy source. Io seems to fail spectacularly on the first ingredient. With its thin atmosphere and extreme temperatures, any water ice on the surface would instantly sublimate, turning directly into gas and escaping into space. But what if not all of it is gone? Is it possible that some water is still trapped deep within Io's crust? The immense heat from the interior could potentially keep this water in a liquid state, creating subsurface aquifers or reservoirs. Next, we need the chemical building blocks of life. These are elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, often summarized by the acronym SYNOPS. We know Io is rich in sulfur. Its other components are less certain, but as a rocky moon, it is expected to contain many of these other essential elements. The intense volcanic activity could then cycle these elements, mixing them and making them chemically available. Finally, we need an energy source to drive the chemical reactions that life depends on. Io has this in abundance. The tidal heating provides a constant and powerful source of geothermal energy. This energy could fuel chemical reactions in subsurface water pockets, creating chemical gradients that primitive organisms could exploit. The recipe, therefore, might just be complete on Io, but hidden deep underground. Even if the right ingredients exist, any potential life on Io would face a formidable enemy radiation. Io is located deep within Jupiter's magnetosphere, which is basically a giant magnetic bubble that traps and accelerates charged particles to, just incredible speeds. The surface of Io is constantly bombarded by this intense radiation, and honestly, it would shred the complex organic molecules necessary for life. The most obvious shelter is the ground itself. Just a few meters of rock and ice would actually be enough to provide significant protection from the radiation. Another potential, though more exotic form of shelter could be the lava tubes. On Io, with its massive fluid lava flows, it's almost certain that a vast network of lava tubes exists beneath the surface. These tubes could provide natural, pre-made caverns, shielded from radiation and potentially large enough to house entire ecosystems. This would be a hidden biosphere, its existence completely invisible to our telescopes and visiting spacecraft. If life were to exist on Io, it would almost certainly be unlike anything we have ever imagined. It would have evolved in an environment completely alien to our own. Imagine microbes that breathe sulfur instead of oxygen. These organisms might derive their energy from the chemical difference between various sulfur compounds found at different temperatures around a geothermal vent. It would be a form of life perfectly tuned to its volcanic home, a true extremophile that would find Earth's oxygen-rich atmosphere a toxic poison. Its discovery would be a profound moment, proving that the genesis of life can follow more than one path. The very possibility of such life redefines our place in the universe. But Io suggests that habitable worlds might come in packages we never expected. This expands the range of possible homes for life enormously. Ultimately, we are left with a tantalizing and profound question. Is Io just a geological marvel, a beautiful but sterile inferno? Or is it a cradle for a different kind of life? A genesis born of tidal fire rather than gentle sunlight. Our journey to Io has taken us across hundreds of millions of kilometers of space. We have ventured into the heart of a cosmic storm, into the orbit of the solar system's mightiest planet. We have seen a world that, honestly, just defies all our expectations of what a moon should be. Io is not a silent, cratered rock. It is a vibrant, violent, and dynamic world. It is a place of perpetual creation and destruction, painted in the brilliant colors of sulfur and fire. Io has fundamentally rewritten our understanding of planetary science. It introduced us to the awesome power of tidal heating, a force driven by the simple, relentless pull of gravity. It is a profound lesson in the hidden mechanics of the cosmos, reminding us that energy can come from surprising sources. This symphony of extremes makes Io a natural laboratory unlike any other. By studying this tortured moon, we learn about the limits of geology. Ultimately, Io serves as a powerful symbol of cosmic diversity. It reminds us not to hold too tightly to our Earth-centric views. Io, with its sulfur snow and magma oceans, demonstrates that nature's imagination is far grander than our own. The universe is filled with wonders, and Io is undoubtedly one of its most fiery and magnificent masterpieces. So, what does the future hold for our exploration of this incredible world? Future missions to Io would be incredibly ambitious, pushing the boundaries of our technological capabilities. Any spacecraft sent to orbit Io for an extended period would need to be heavily shielded, a true robotic battleship designed to withstand a constant storm of high-energy particles. But the scientific rewards would be equally immense. A dedicated Io orbiter could map the entire surface in high resolution, monitor volcanic eruptions as they happen. The ultimate dream, of course, would be to land on the surface. This presents an even greater set of challenges. Where could you possibly land safely on a world where the ground is constantly being repaved by lava flows? Even more ambitious is the idea of searching for life. This would require a mission that could not only land, but could then drill or melt its way through kilometers of rock and sulfur ice. The discovery of a second, independent genesis of life within our own solar system would be one of the most profound discoveries in human history. We began this journey with a mystery, the secret of Io's fire. We found the answer in the immense gravitational power of Jupiter and the clockwork resonance of its neighboring moons. But in solving one mystery, we have uncovered a dozen more. Io is a world that continues to challenge us, to push the boundaries of our knowledge and our imagination. It is a puzzle box where each new piece of information reveals a deeper and more complex picture. It forces us to ask fundamental questions about the nature of worlds. These are not just questions about a single moon, they are questions about the rules of the cosmos. Io will continue to be a beacon for exploration, drawing us back with the promise of new knowledge. Future generations of scientists and engineers will devise new ways to study it. Io will wait for us, its volcanoes patiently churning, its heart of fire continuing to burn brightly in the outer solar system. So, the next time you look up at the night sky, think of Jupiter. And, remember the small, colorful moon dancing close by its side. Remember the world of fire and ice, of towering mountains and fountains of sulfur. Remember Io, the solar system's hottest secret. It is a reminder that our universe is a place of endless wonder, filled with worlds more strange and more spectacular than we could ever dream. Its enduring mystery is an invitation, a challenge to our species to keep exploring, to keep questioning, and to never stop reaching for the stars.